In our previous video, we have discussed the 6 major steps for ABG diagnosis, and today we will solve some problem. The question 1. pH is 7.50, which is increased, it will produce alkalosis. Partial carbon dioxide 47, it will produce acidosis. Bicarbonate 30, it will produce alkalosis. Anion gap 20, which is normal. So, the primary problem is due to metabolic cause, because here is alkalosis and here is also alkalosis. So our primary problem is metabolic alkalosis. Metabolic alkalosis. Okay. So we need our expected partial carbon dioxide level, and because it will compensate it by partial carbon dioxide, so our expected PCO2 is equal to, we know the formula, bicarbonate plus 15 plus minus 2. Here the patient bicarbonate is 30, so it is 30 plus 15 plus minus 2. Okay, it is 45, and the range is 43 to 47, and the patient bicarbonate is within the range, and here all the parameters are abnormal, so we can say it is a partially compensated metabolic alkalosis. So our final dx is equal to partially compensated metabolic alkalosis. Okay. Next, question 2. Here the pH, partial carbon dioxide, bicarbonate all are in normal range. Anion gap, it is not normal. Anion gap 20 is normal, so it is high anion gap. Okay. So we need to calculate bicarbonate gap. Bicarbonate gap is equal to, we know that patient's bicarbonate plus patient's anion gap minus 12. Here the patient's bicarbonate is 25, so it is 25 plus anion gap 23, 23 minus 12. Okay, 25 plus 11. Okay, it is 36. Okay, we know that if the bicarbonate gap is greater than 30, it is high anion gap metabolic acidosis plus metabolic alkalosis. So here all the parameters are normal except anion gap. So our final dx is high anion gap metabolic acidosis with metabolic alkalosis. Okay, this is our final dx. Let's come to question 3. Okay, in question 3, the pH is decreased, acidosis, partial carbon dioxide increase, it will produce acidosis, and bicarbonate 30, it will produce alkalosis. So what is the primary problem? These two will form acidosis. Partial carbon dioxide, it is a respiratory compound. So our primary problem is respiratory acidosis. Okay, so we need to calculate the expected partial carbon dioxide. We know the formula. Expected partial carbon dioxide is equal to 24 plus change of carbon dioxide into 0.1. So what is the change of carbon dioxide? Change of carbon dioxide is equal to, here the carbon dioxide is 50 minus the normal value of carbon dioxide, which is 40. Change of carbon dioxide is equal to 10. Okay, so it is 24 plus change of carbon dioxide 10 into 0.1. It is 24 plus 1 is 25. Okay, so patient's bicarbonate 30, and our expected 25. Patient bicarbonate is greater than expected bicarbonate. Bicarbonate is greater, it will produce alkalosis and it is a metabolic. So our final dx is equal to respiratory acidosis with bicarbonate is increased, so it will produce metabolic alkalosis. Okay, so it is respiratory acidosis with additional metabolic alkalosis. Okay, it is our final dx. Yes, here is the last question. pH is 6.67, it is decreased, so it will produce acidosis. Partial carbonate is 33, it is decreased, it will produce alkalosis. Bicarbonate 5, it is decreased, it will produce acidosis. So what is the primary problem? It is acidosis, pH acidosis. Bicarbonate also indicates acidosis. So our primary problem is metabolic acidosis. Metabolic acidosis. Okay. So you need to calculate our expected partial carbon dioxide level. So expected PCO2 is equal to patient bicarbonate level plus 15 plus minus 2. Okay, bicarbonate level 5. Okay, 5 plus 15. Okay, it is 20 and the range is 18 to 22. Okay, here the patient's partial carbon dioxide, which is 33, our expected is within this range 18 to 22. It is greater than our expected partial carbon dioxide. Means that patient partial carbon dioxide is increased, it will produce respiratory acidosis. It will produce respiratory acidosis because the partial carbon dioxide is increased. Okay, so we'll found an additional respiratory acidosis. Okay, acidosis. It is our first problem. Then we found respiratory acidosis also. Here anion gap is high, so we need to calculate the bicarbonate gap. Okay, so our bicarbonate gap is equal to, we know the formula, patient's bicarbonate plus patient's anion gap minus 12. Okay, here the patient bicarbonate is 5. Okay, 5 plus anion gap 40. Okay, 40 minus 12. Okay, so it is 5 plus 28, which is 33. Okay, our bicarbonate gap is 33. So bicarbonate gap is greater than 30, so here is an additional metabolic alkalosis. Okay, so we found 3 problem here. So our final dx is equal to metabolic acidosis with respiratory acidosis with metabolic alkalosis. Yes, this is our final dx. Okay, so we can say here 1 respiratory disease and 2 metabolic disease, so it is a triple acid base disorder, and in this math the dx is respiratory acidosis with metabolic alkalosis. 2 problem is present in this case, so it is a mixed acid base disorder. Okay, and in question 2 our dx was metabolic acidosis with metabolic alkalosis, so it is a mixed acid base disorder. And in question 1 the dx was partially compensated metabolic alkalosis, so it is a simple acid base disorder. Thank you. Please like, comment, share and subscribe our channel.